differential equation. And the problem of the differential equation is a continuous. Continuously is very important. And so the mass transport continues to flow and usually analyzed by continuum model. But I explained the RBSM, and RBSM based on the discrete mechanics. They don't keep the continuity in the analysis. And discrete is the opposite, and the discrete is the feature of the RBSM. So the concept is different. So I consider I select the trust network model considering the constancy with concept of RBSM, because the RBSM composed by the link of truss element. It's connected by the springs, and spring is the same with the truss element. And when we use the truss element, one-dimensional diffusion equation is employed to carry out mass transport. So it's very simple and easy to simulate the mass transportation. This table shows the several mass transport problems. You know the molecular diffusion is very important. So one example of the molecular is a chloride ion. It strongly depends on the corrosion problems. So if we solve the molecular diffusion, we use Fick's first law, this equation. And temperature. Of course, thermal stress is very important. So we have to simulate, calculate the temperature distribution depending on the time in early stage of the concrete structures. And the equation solved by the Fourier's law. And water move is very important to drying shrinkage. So then the Darcy's law is used, applied. And electric. What is the electric problem in civil engineering? Corrosion is an electric problem, chemical electric problem. And electric problems is solved by the Ohm's law. These equations are the same, only the name is different. So every mass transfer can solve same way using simple truss element. Once we make some problem, we can solve all phenomena. And of course, truss element is very simple. So when we consider other problem is fire. In fire, we have to consider the movement of the temperature, high temperature, and the water, or the relative humidity, or the vapor pressure. So then we can consider the combination of the temperature and water. So most problem of the durability can solve the mass transport in these equations, in these styles. Okay, I skipped this part. And so the next I will show the result of the application analysis to corrosion problem. Today I prepared the durability problem about the corrosion. And we prepared the two results. One is the crack propagation and mass transport due to drying shrinkage and corrosion. Before I explain my result, I like to mention about again durability mechanics. In this case, due to corrosion. So this figure shows the lifespan of RC structures in corrosive environment. And the damage level is classified to initiation, propagation, acceleration, deterioration. And initiation stage, mass transport problem is important, because in initiation stages we have to consider the mass attack of the chloride ion, penetration of the chloride ion in the concrete. And once a chloride ion come to steel reinforcement part, corrosion occurs. corrosion start. And then is at that time the propagation stage. And this stage, the chemoelectrical problem is important. So I mentioned corrosion is an electric problem. And after that, acceleration and deterioration stage is a material and structure problem is important. Cracking occur and the final deterioration process, performance of the structure will be deteriorated. So in order to simulate the life cycle due to the corrosion, you have to consider the all stage. But in this stage, of course, in this stage, I cannot consider it. But I hope in near future, I consider all stage. So today I show the result of the several stage and the simple result. This is a specimen. RC bar in which the bar of 1.0% is arranged at the center. Very simple specimen. And then the relative humidity and chloride ion density of the is assumed as environmental condition. So I consider the drying, effect of the drying, shrinkage, and effect of the attack of the chloride ion and corrosion. And when we consider the corrosion, we have to consider the corrosion expansion. Corrosion expansion effect. First is the corrosion expansion, and then the cracking occur due to the expansion. So we consider the penetration of chloride ion, and once the value around the river exceeds threshold values, we calculate comparing displacement using this equation, and we apply the displacement near the point of the Voronoi particles. And other feature of this simulation is that it considers moisture conductivity and the diffusion coefficient of chloride ions through cracks are assumed to have higher value than that of the bulk concrete. Of course, the mass transport fastly through the crack more than the bulk concrete. So this is the analytical result, crack pattern, relative humidity, and content of chloride ions. At 50 days, this is just a simulation, so the time is not so important. At 50 days, many microcracks occur at the surface of specimen due to the effect of drying shrinkage. So drying occur from the outside of the specimen. And of course, the chloride ion penetrate from the outside. And 250 days, major crack propagate to river and mass transport through the crack due to the higher value. And at the 600 days, mass transport through crack accelerate, and crack grow along the river due to the expansion of river corrosion. So because after the corrosion, we consider the comparing displacement along the river, so crack propagate like this way. So let's see the animation of this one. I think this animation is interesting. So drying start and dry shrinkage crack occur, surface, and suddenly the crack, major crack occur. And chloride ion penetrates through the crack. And after the corrosion starts, crack propagate along the river. So I think this behavior is similar. This is just simulation, but this behavior is similar. This simulation method has the potential to simulate life cycle of concrete structures. And this is one part of the doctor thesis of the Dr. Wolfgang. And this result is just simulation. And I prepared other result is I simulate electric corrosion test, and I compare with the test result of the analytical result. So I choose the test result of the electric corrosion and some analysis, local corrosion process, analysis of reverse and crack propagation analysis due to corrosion. First is please confirm the crack propagation behavior of the corroded specimen. So a corrosion test is was carried out like this. So many specimens was tested, and the purpose of this test is to evaluate relationship between surface crack width and internal crack propagation, because surface crack, when inspection of the concrete structure is we can observe surface crack. So surface crack is a very important information, but it's observable information. But what information we know? Of course, we would like to know the damage of concrete structure. So damage of the concrete structure is internal, strongly depend on the internal crack. So this is a strongly related damage information. So we have to know the relationship between the surface crack and internal crack. So to confirm the relationship, we carried out these tests, and this is important for maintenance process. So this is the test procedures. Surface crack width is measured by displacement transducer during the test. And corrosion amount and surface crack width are measured like this. So there are many lines. So we tested many specimens, and we stopped different damage level. So the line stopped the different point. And sometimes, and after the test, we cut the specimen and check and measured the internal crack. What kind of the internal crack occur inside of the specimen? And also that we observe the corroded section of the reverse. This is that we carried out many structures, many specimens. So this is one test result. This is a relationship between the corrosion amount and surface crack width. And this is so the information of observable information in the inspection work from the surface. And this is the internal crack propagation, corrosion amount, and relationship between the lateral crack length. First stage, surface crack occur, some corrosion amount. And next, surface crack with increase rapidly. However, the internal crack does not propagate in the stage. After that, the speed of propagation becomes slow. Speed of the surface crack width becomes slow. But internal crack length increase rapidly. Finally, the length converge varies. So the surface crack width and the relationship of the surface crack with the propagation of the surface crack and internal crack is quite different. If it's strong relation, it is easy to predict the damage of concrete structure. But from this result, we can understand we cannot predict the damage of concrete structure only from the observable information of the surface crack. That point is very important. However, this is just one example, and the relationship between the internal and surface is some function of the cover thickness and the space of the river and etc. etc. So we have to consider these effect parameters to affect this behavior. And then it is difficult to understand. Concrete structures, there are many conditions. So this result, is it possible to this wall? I think no. So we need computational method to apply the many places. This is the merit of the computational method. And let's think about the, let's confirm the internal crack pattern. At first stage, the vertical crack initiates from the surface. Crack initiates from the surface. And then internal lateral crack propagated from the river. And internal crack and surface crack propagate. So how to simulate this behavior? This is a simulation process. I explained briefly. First, electric potential is calculated using the torus network model based on the Laplace equation. So we solve the electric current distribution and movement of the electric current because this is an electric corrosion test. And next, we calculate corrosion amount using the Ohm's law and Faraday's law. So using the electric potential, we can calculate the corrosion current. And using the corrosion current, based on the Faraday's law, we can calculate the corrosion amount. And then we assume expansion pressure using this corrosion amount and simulate using the RBSM, we can simulate the cracking pattern. This is the process. And the simulation is a test result is a simulation, and this is an analytical model. So we consider the electric potentials as boundary conditions. And in this case, we model the river is modeled also by rigid body. And one point of this simulation is how to use Faraday's law. Faraday's law is a key point of this situation. But it is known that the corrosion of river in concrete is not identified by Faraday's law due to the effect of precipitation. Faraday's law can apply in the atmosphere, but in the concrete, it cannot apply directly. So we consider some reduction factor to consider the effect of the surrounded concrete. But the merit of the RBSM, we can simulate crack directly. Finite element method is no. RBSM can. So at the crack part, this is the atmosphere, so atmosphere conditions. So at this point, only this point, we consider cracked point. We consider the eta equal 1. That means that we apply directly the Faraday's law. We consider the effect of the concrete to use Faraday's law. This relationship is the accumulated corrosion current, and corrosion amount. This is a test result. So this is when we use the Faraday's law is the overestimate. But we consider the effect of the concrete and effect crack. We can simulate reasonably of the test result. This simulation is very important because this is accumulated corrosion current is directly related to the time. It's just time. So we can simulate effect of time. So